This is going to lay out the basics of systems engineering and give you a sense of the flow. Now we'll start out with drawing several boxes here. First, we're going to talk about needs. So what does the customer need? You remember earlier we showed that it started with a customer request answering some pain point. And then we're going to do something different here. We're going to move into requirements. And then finally, the product, the design, and then the product itself at the end. Okay, so we'll see that. Now, we start with the customer request. And there we talk about what's called customer needs. This is what is driving the customer in the first place to give us money. Okay, so that could be anything from we need a refresh for technology, we need a new, for instance, satellite capability for a communication satellite. It could be a automobile situation where we're at an auto factory, we need to just have a bigger engine. So that could be a need. Needs can come from different places. It can come from a government customer, in which case we're given needs and requirements sometimes. Hopefully they're well written. Otherwise, in consumer environments, the needs might come from marketing or come from a sales survey or different customer engagement activities, and we collect needs that way. But it's basically what we need to measure the product against or validate the product against in order to have a successful product. Okay, so now the needs can come from, again, these surveys, interviews, sometimes the customer itself. So you've got this collection in here of needs, concepts of operations in this box here. Then you take the needs, you can go to requirements. Okay, so if you go over here, now you've got requirements. And these are statements, a lot of times either in a model or some kind of format. It could be just a simple Microsoft Word document. These are statements that you can design to. So if needs talk about the pain point, then the requirements speak to something can design to. Sometimes they call these types of requirements design input requirements because they're the input to the design. But once you have the needs and the requirements, then you can start doing your design. Okay, so now we're writing code, we're cutting metal, we're in the shop. We have something that we've used our creative juices to produce. Okay, design could be some of the most fun activities in engineering. You're really getting in there. You're creating the wheel. You're creating the new engine block. You're writing code based on the requirements that, when run, will speed up the system or produce a new graphic art system, whatever it is. So you took this pain point. We have now something we can design to, and then we produce something. At this point, it's drawings, prints, maybe a software architecture. Maybe we haven't coded yet, but we're just architecting our solution. This is something we can build. And I'll use a hardware analogy, but the same applies to software as well. So now, again, system engineering, we've gone pain point. Now it's something we can design to. Broken out the needs. Then we've created something that we can build. These are prints, software diagrams, maybe draft architectures, or even baseline architectures. Now we're able to do the final step, which is to get the product. Now I hate to use the word thing, so I'm just going to call it the item or system. I'll do item, I think it's easier, so. We can put system there too. So the item or system, that is the actual object. Now this item or system, now we can test that. We can run tests because this item or system has to meet our requirements and ultimately satisfy the needs. So here's where we have some feedback going in. I'm going to try, I'm going to do this in black here, but so here, now that we test it, we can verify. I'm going to draw these lines down below. First, we verify that the system was built to print. Okay, we had the design specs, were the design specs actually implemented in our production shop. And there we get into things like quality assurance or QA, production quality. That's not the scope of this session, but there's usually a system that ensures if you have a print and it says 3 inches, you've cut metal to 3 inches. So first you verify, was it built to print? Now you also have to verify this against the requirements themselves. So these are the design input requirements. Were the requirements met? And here you can actually use quite a bit of money and resources to test the products to see if the requirements were met. So we have something we can design to, a series of statements or a model. Was it implemented to where we meet requirements? And a requirement could be a weight requirement, it has to weigh less than 5 pounds. It could be a performance requirement, 0 to 60 in 4.2 seconds. Those are types of requirements. Now the final verification is you need to verify, and now you get into what's called validation. So you've got an item or product. You will then circle back all the way to the front. Does it relieve the pain point? Okay, so you're validating that the needs are met. So again, we validate to needs in general. We verify to requirements. If you were to take one thing from this session, get the difference between verification and validation. I can refer you to the literature in COSI, COSI.org, their International Council of Systems Engineering. I like their literature quite a bit. There are other standards out there. The ISO, the IEEE has something called 15288. I'll definitely do the 2015 version or later that describes all this in much, much more detail. There's an IT version out there too. It's NIST 800-160, I believe. Message me for the exact number there, but you can do this for IT systems too. But we validate to the needs. Did the system relieve the pain point? If it didn't, the customer's not going to be happy, and they're going to wonder why they wrote us the big check. And earlier, remember, we had the request, and we gave them the product. The request needs to be met, or they'll find someone else. So, now, again, this is a simplification of other publications that are out there, but this will give you a context. For the most part, engineering is a flow. It's a flow where there's back and forth. You can see the forward path where we have needs, we have customer interviews, we come up with some requirements. We don't just go to design, okay? We don't skip the pain point and then start designing. That's poor form. That almost guarantees we're going to miss the mark. We just refine these requirements. And what we do there is we also, once we have these requirements, we will check these requirements to make sure, before we do this, to make sure that they meet the original needs. So we're going to write these. We're going to double check to make sure, hey, customer, if with this requirement set, if we build something that meets these requirements, are we going to meet your pain point, at least as far as you can see? Are there any other caveats? Oh yeah, it has to be blue. I mean, I'm making that up, but there could be just some, we call it a red herring idea out there that just we didn't think of. But when we check these requirements against the needs, we can catch things and then save money downstream. Then finally, the design. Before we build, it's good practice to then fold back and just make sure the design will satisfy the requirements. Okay, there's a check there. But also, that the design as implemented will satisfy the needs. Again, sometimes the customer can say, oh, it has to fit within a 50 centimeter cubic area. Okay, well, that's the requirement, and we need to know that. If we build something bigger, it's not going to work. So doing the process in green along the way will ensure that this product that we build, by the time we're verifying, we build it, the black is we've built it and we're verifying it. And then by the time we validate it against the needs, we're going to increase our chances of just getting the right system. So again, the normal process is we have engineering flow, to yield a system. Okay, along the way, we'll do these checks to make sure we're on track, and then at the end, we do verification, for production verification up front, then requirement verification. Do we get the requirements satisfied, and then ultimately, for a validation step or product acceptance, we're going to make sure our pain point was satisfied here. It's very balanced. There's a lot of give and take. There's a lot of flow back and forth. There are other entities. There's corporate guidance. I'll just write corporate here. These corporate guidance can influence this as well. They can give requirements that we need to take into account. A lot of times they describe how something needs to be done. It might mandate a certain quality check at each point. These check with your boss, check with your manager. They're an advanced topic, but they can be in the space too. But the point of this was to give you the basic flow for systems engineering, the technical work that's involved with going from a request to a product follows this basic pattern. Okay. Now, your assignment could be anything from work on a test plan down here. Could be doing a requirements review, in which case you look at the requirements and make sure they fit the needs. Maybe you're a designer and you're in this space. But even if you're a designer, you're going to have a much more successful career if you can understand where this fits in the big picture. So that was a lot in one swoop. But you now have the basic context of systems engineering and the basic flow of how systems engineering will give you either the right product or something very close at the end of the time and the money. Hey, reach out if you have any questions, message me directly, and I wish you luck in your systems engineering career. There's no better time to be a systems engineer. The demand is intense, and you're going to have your pick of projects, your choice, if you can master some of these basics and understand the context.